Okay, here's another exponential growth and decay. This is actually decay. This is number 5. Population of a city follows the exponential law if the population decreased from 1,200,000 to 1,100,000 from 2010 to 2014. What will the population be in 2022? All right. So again, we have an initial population in 2010. I guess that's our starting point. So our p sub 0 would equal 1,200,000. Okay. So we've got that, but we don't have the k, and t is usually an open variable. So, but we do know that we have 1,100,000 after 4 years. That's over here. In other words, we have 1,100,000 after 4 years. So we can use that to find the k. So first of all, we've got to find the k. Find k. All right. So we know we have 1,100,000 when t is 4. So my initial population is 1,200,000 times e to the k. I don't know k, but that's when time is 4 years. All right, so I can use that to find k. So I divide both sides by the 1,200,000. Now this just, all these zeros cancel, so I just end up with 11 over 12, so that's nice. And that equals e to the 4k. So all these big numbers got real small fast, so I take the natural log of both sides. Put the 4k in front. The natural log of e is 1, so I just divide by 4, or multiply by 1/4, same thing, and I've got 1/4. And I could also write this as 0.25. There's my k. So now I can put this in my formula. Population at time t equals p sub 0 times e to the 0.25 ln of 11 over 12. Actually, my p sub 0 is given as, my initial population is 1,200,000, so it's actually equal to 1,200,000 times e to this k, 0.25, times the natural log, that's a t, forgot my t, 11 over 12 t. So there you go, I got a little crooked there because I'm writing at an angle. Okay? So that's what you've got. So they ask you now, what will the population be? What will the population be in 2022? So 2010 and 2022 is 12 years, right? 10, 11, 12, 13, 14, 15, 16, 17, 18, 20, 12 years. So we want to know population of t when t is 12. All right? So here we go. Let's put this up a little bit here. So now we have the k. We can find the population at any time. So P of 12 equals my times e to the 0.25 times ln of 11 over 12 times t. Oh, I'm sorry, t is going to be what? 12. Excuse me. Now this works out nicely. You know, you're not going to have to put as much stuff in the calculator because 25.25 is the same thing as 1/4, and what's 1/4 of 12? That's just 3. So I could rewrite this as P of 12 equals so 1/4 of 12 is 3, so 3 times ln of 11 over 12. Now that should be easy. 3 times. Put your calculator. I can just write 12. 11 divided by 12, like that, and I should get it. Okay? So you get out your little $1.99 calculator, put it in like that. On 1, 2, it's my 127,000. Shift, natural log for E, put my parentheses in, and then I've got 3 times 3, natural log, parentheses for the fraction, 11, divided by 12, parentheses for the fraction, parentheses for the log. So if I did that right, I should get an answer of 924,305.56. So P of 12 is that. So you can see the answer there. 924,305.5556. We can round that off. Okay, so population P12. It's approximately 1,305. So there's your population. Okay, see it over there on the right. 124,305.56 people. Okay. So that's not too bad. That worked out nicely because we could reduce. If you can't reduce it, you just have to multiply it out, but that should be okay. Make sure you practice on your calculator so you know how to use your calculators because sometimes that'll slow you down. Like I said, that's why I did it with these calculators. Okay, hope that makes sense.